Hello interwebs, welcome to Let's Fix Computers. I've got this this HP all-in-one over here, and apparently it doesn't post and possibly has a scrambled BIOS. Anyway, let's plug it in and see what it does. Ooh. Okay. Okay. Why do they always have to beep at maximum volume? I get it. It's because in a repair center, you'd have like a row of them or something like that, and there's some poor sod technician who's working on 20 machines at the same time and needs to hear one beep from across the room or something. Whatever. Anyway, it said the BIOS recovery files cannot be found or the files are corrupted. Using another computer and a USB flash drive, download the latest BIOS from the HP website and create a BIOS USB recovery drive for the PC that needs recovery. Insert the BIOS recovery drive into the PC that needs recovery and restart the PC. To learn more about creating a USB recovery drive, go to the HP website. Okay, let's do that. Outstanding. Very well. Okay, well let's just try downloading the latest BIOS for this device then. This thing is a 24-D00... Sorry, DF? I think that's a DF00. DF00? Yeah. 32NA. Right, BIOS system firmware. Or BIOS. Great. That's incredibly unhelpful. Right, it looks like they changed the name of this at some point. Oh no, but there's December 2424. Whatever. BIOS has the most recent stuff in it, so let's try that. Right, let's download the latest update. 12.5 megs isn't very big. But let's see what we actually end up with. No, I'll download manually. Might just be compressed. Here we go. So HP BIOS updates are actually kind of useful because we can update the computer we're on if applicable, which currently it is not. We can make the USB recovery flash drive, or we can copy the BIOS image out. So if we're actually flashing the BIOS chip on the device, it will allow us to just extract the core image, which is nice. Let's try doing the recovery flash drive first. Just let me plug in a flash drive. Okay, let's use this. So I'll format it just so it's in whatever format the thing wants it to be. There we go. Flash drive has been successfully created. Okay, so power off the device, insert the flash drive into a port, power on. The device may reboot up to 3 times. So let's just try doing that and see how far we get. So I'm just plugging the flash drive into the first USB port, not for any specific reason, but I don't know. All right, I've plugged in the power, and we're just going to turn it on and just let it run. I'm expecting it to beep angrily, and I've put some masking tape across the front of the speakers to hopefully quieten it down, but sorry if it's loud and angry, folks. Auto recovery never works. I'll try moving the flash drive to the end USB port. I'm not expecting that to make any difference, but the next stage is that we have to tear this thing apart and desolder the chip. So, yeah, let's... whatever. One last try. Let's see what it does. No, that's enough. We're taking it apart. Anyone in the comments who knows why that didn't work, let me know. I would love for it if the automatic recovery systems worked, but whatever. Okay, I'm going to lay this thing down on the bench. We're going to open it up, get the motherboard out, and have a look for the BIOS chip. Right, so to get into these HP all-in-ones, you usually start underneath by popping off this cover around the stand. And that gives you just enough access to get to the screws there, and there's one there to remove the stand. Sorry if autofocus is going a little bit wild at the moment. I will probably lock it off in a minute. There we go. Now I'm going to try and remove the chin bar. So this, I think, should just pop off with a little bit of encouragement. Sometimes they've got some screws in from the bottom, though. So I have already checked and I'm not seeing any, but watch out for that. Now we need to lift the LCD panel out, so we've got a couple of screws securing that in. So I'm going to go along the bottom and just remove all these silver screws. And before I lift out the LCD panel, there's some clips around the sides for this. So I've got just a wide spudger here. You often get these with replacement batteries for laptops. I don't know what else to call this. Plastic palette knife, wide spudger, I don't know. This is what I use. So I'm going to just gently ease that down the side of the screen. I have a couple of these, so I usually just use one on each side. And then I'm going to try and lift the screen up. Oh, there we go. Jam that under there so it doesn't fall down again. This is ready to go. Just gently wiggling. Oh, but don't be too hard, because if we break the screen on this, then that's expensive. What's holding me up? There we go. It just needed a little bit of a tweak along the top. And now I'll lift it up and I'll pull the whole thing upright so you can see this bit. As we open it up, you can see we've got this ribbon here. We need to disconnect that. And we've got an LCD, we've got a backlight power cable as well. Ew, hard drive. Cool. We should also definitely have a conversation with the customer about replacing that hard drive. Because, yeah. These hard drives in all-in-one computers are prone to failure because the grand total sum of cooling it has is this tiny little bypass from the main cooling fan, which is very asthmatically blowing vaguely in the direction of the hard drive with no exhaust. So yeah, A, the hard drives cook themselves, and B, hard drives are just slow. You should just know. Yeah, I'm surprised this one has a hard drive, if I'm honest. I thought it would have an SSD in it. So we'll have a conversation with the customer about upgrading that while we're here. However, none of that is relevant to what we're currently doing. Let's make the computer work before we talk about upgrading its storage. So let's just zoom into the motherboard a little bit and have a look around there. So there are a couple of points of interest here. First, while I'm at it, I'm going to quickly check the clock battery, the real-time clock battery, or the CMOS battery, or whatever you want to call it, which is here. I'm just going to check if that is toast or not. So let's just quickly throw this on screen somewhere where the screen is visible without reflecting. I'll put my black probe on a screw hole and we'll just check the top of that. That's stone dead, which is kind of interesting. I am thinking I should probably try a different BIOS battery before we do anything else. Maybe that so the CMOS battery is not responsible for storing data on the BIOS. So the BIOS chip, which incidentally is there, and I'll talk about that in a moment, the BIOS chip is not powered from this battery, which is a very common misconception. A lot of people believe that this battery keeps this guy powered when the computer is off, so it doesn't lose its contents. But what actually happens is the BIOS chip is non-volatile. It's an electronically erasable, programmable ROM, an EEPROM. It does not lose its contents when it loses power. And this is where all your stuff is stored. Now, this battery here, this is supplying a 3-volt signal into the PCH, the platform controller host, which on this computer will be on board the CPU. There'll be 2 dies on the CPU, the core and the PCH. And the PCH is doing all of the real-time clock stuff. So what happens is there is power into the RTC circuit of the PCH from this battery. Now, when the 3-volt signal from the battery is removed because you take the battery out, or if you short the CMOS reset jumper, wherever that is, that signals the PCH to reset the BIOS settings. And the next time it powers up, it will erase the NV region of the BIOS chip, which is the section in BIOS where user settings are stored. So removing the battery does not erase the BIOS chip or any settings from the BIOS. It tells the PCH to erase those on the next power up. This is why the behavior of a flat BIOS battery can vary. It just depends on the platform. However, because this battery is stone dead, that might be why it doesn't want to self-recover, because the PCH and the BIOS system in general is thinking that someone is trying to reset it and update it at the same time. Maybe it's getting confused. So I'm going to replace this battery first, and then we'll see what happens. I'm also just going to disconnect the speakers while I do this so we don't get deafened every time it turns on. Right, we've got the same thing, BIOS corruption detected. No angry beeps this time because we unplugged the speakers. I'll let it reboot and see if it actually tries to initiate a BIOS recovery this time. No, same thing. Okay. I didn't think that was going to work, but it was worth a try just in case. So this guy here is called a SOP8 chip. That's SOP8. And this kind of package is pretty uncommon on modern systems. Pretty much the only SOP8 chip you're likely to see in a modern computer or laptop is going to be the BIOS chip. The other type of BIOS chip you'll encounter is WSON8, that's WSON8, and that is a flat package that looks like this, I say, putting a picture of a WSON8 chip on screen in post. These are the 2 kinds of chips you're looking for. And the big giveaway that you found the one that's actually the BIOS chip is it will be by a brand of EEPROM. So let's come under the microscope and take a real hard look at this one. And as you can see, this one's a WinBond chip, and WinBond are an extremely common manufacturer of EEPROMs. Like most laptops and computers use WinBond chips. Not all of them, but it's very, 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 very common. And then the actual chip markings, here we've got 25Q128, and 25Q is the series, and 128 means it's probably going to be 128 megabits. So again, we've got all of the markings that say this is an EEPROM. And the final nail in the coffin is if you type 25Q128JVSQ into Google, it will come up with the datasheet for an EEPROM. So that's how we know we've got the BIOS chip here. Now, it is worth noting that you will, a lot of motherboards might have more than one BIOS chip, because you might have the system BIOS, you might have the VGA BIOS for an onboard graphics card, and you may also have the Thunderbolt BIOS, because a lot of computers with Thunderbolt ports will have a separate firmware chip for the Thunderbolt BIOS, or firmware. So keep that in mind. This one, it's easy to tell this is the system BIOS because it will be the largest chip on the board. 128 or 256 megabits is a fairly large chip for a system BIOS. It's also right next door to the CPU. And the CPU is the chip that's going to be talking to this guy. So again, you're probably going to find it very adjacent to the thing the chip is for. So that's how we know it's the BIOS chip. So let's desolder this from the board and we'll take a closer look at its contents. So let's see. I can actually get away with doing this in situ, I think. Normally I would say take the motherboard out, but in this instance, I'm just going to touch up those legs with some leaded solder just to make them easier to move. And I'm just going to go straight in with the hot air on that. So let's give that a whirl. So I've put the chip into a socket adapter and into my CH341A programmer. So this is a CH341A version 1.7, and it's just in a 3D printed box just to make it easier because these are kind of usually just bare circuit boards. So the CH341A, the two major flavors you see it in are the black circuit board version and the green circuit board. The green circuit board, which is what I have here, has a voltage selector switch on it, which makes it so much more user-friendly. So I highly recommend spending a bit extra on the V1.7 or higher version of this guy. So I've set it to 3.3 volts because this is a 3.3 volt chip. Again, you can Google search the chip number, look up the data sheet, and very quickly find out if you have a 3.3 or a 1.8 volt chip. So I set that to 3.3 volt. And now in Neo Programmer here, I'm going to go ahead and just click Detect. And from here, it's picked up a couple of candidates. And W25Q128JV, that's the closest match we've got. There's a good chance that all three of these will work, but JV is an exact match. So we'll select that. And I'm just going to hit Read. And that's going to start getting a read of our BIOS. Obviously, what we're reading out here is probably scrambled, but we're always going to save a copy of what's already on the chip first. Because A, we might need to get serial number data, Windows product key data, or something like that out of it later on. And B, it means that if we make a complete hash of this, we can restore the computer to the way it was when we started. Now, while that's reading, I'm going to run the BIOS updater again, and I'm going to extract the image from it this time, so we've got that at the ready. So we'll just wait for this to pop up. Next, copy the BIOS image to any file location. And I've just saved this out to a working folder that I'm using here. I have a folder called ROM dumps, and I make a new folder for every board I work on in there where I save just any files that I'm currently working with. So I'm keeping track of different BIOS versions and dumps and so on, so I don't end up drowning in all of the nonsense that I've got. Right, that's done. Our BIOS read is done, so we're also going to save this out. And we'll save that as dump.bin. So now we've got a dump file and we've got a clean image from HP. Notice how both of these images are exactly the same file size, 16.384 megabytes. So that's how we know that we're on the right lines here. All of these file sizes are identical. It's really important. Right, now that's done, I'm going to open up our clean image from HP. So I'll select our HP image. And I'm just going to flash this directly to the chip. Now, we might need to add in serial number data. I'm not sure if we can do that after the fact. For the time being, I'm just going to flash this onto the chip, boot the computer up, and just see if we're getting somewhere. So let's go ahead and do that. I'll make sure that all of the options are selected in Neo Programmer. So we're going to switch off Write Protect, erase the chip, make sure it's erased, write the chip, and then verify the write. Go. Programming is complete, so let's put that guy back on the board. So I'll just position that down. I'll add a little bit of flux in just so we get some nice clean joins, and I'll just reflow that with some hot air. Cool. Let's stick a BIOS battery in there, plug in a screen, and see if we have achieved anything. Alright, here goes nothing. Interesting. It's stone dead. Definitely got things plugged in correctly. Okay, let's just take the power off again. Alright, we've got a white light on the back. Yeah, 0 response from the power button. Well, that's very disconcerting. Okay, that would suggest that there's something wrong with the soldering, or we've just flashed a completely incorrect BIOS, like completely wrong. So firstly, I'm going to check my soldering. And yeah, that's on properly. There's no bad joins there. The power button is plugged in correctly. Well then. Okay. Let's take a closer look at the BIOS I downloaded. So going back to the HP website, I downloaded the newest dated BIOS, which was this top option here. And actually, we've got a version F49 as opposed to F44 there. The versioning here is really confusing because these two versions apparently dropped on the same day. Whatever. But also on the older one here, we've got this one here. This is version F54, but is December 2024. So I'm not sure what's happening here. I am going to try this one instead, this version F54, because that seems to be the newest version. We've got another one down here that is also F54 and came out a couple of days prior. We've also got two different versions. We've got consumer desktop, and then we've got consumer commercial desktop. So the one I used was consumer desktop. So I'm going to try this one here and try my luck with that. I'm kind of flying blind here, but I'm just going to try another one from the HP website, see what happens. So I'm going to go through the same procedure again, flash that onto the chip, and we'll see if that one works. One reflash later, and let's try again. Right, power in. Got a white power light on the back. And our survey says, still dead. Uh-oh. Okay then. Right, I'm going to reprogram the BIOS chip again. I'm going to restore the original dump image that I took from it. I'm going back to square one to see if the computer powers up. I want to find out if there's a problem with the image or if I've just broken the computer even more than it already was. So, stand by, we're going around again. We're back again. So I flashed my dump file back onto the BIOS chip, and now the computer switches on and we're back on the original fault screen. So you can see how having the wrong BIOS on a computer can completely alter things. It looked like we had a no power situation there, but it's actually just that the BIOS was just clearly no good. And once we restore the dump file back to it, we can actually get back to our start point. So this is why it's really important to retain an original copy of what was on the computer when you started. So we're clearly missing something with the clean BIOS that I've downloaded. Either it's the wrong one, which I find hard to believe because I typed in the serial number to the HP website to just be absolutely certain I was downloading the correct BIOS, or there's an issue with that BIOS image. Perhaps it's only an update file and it doesn't contain the complete image or something like that. Now, I find this hard to believe because if it was simply an update file that was only a partial image, I would expect the file size to be wrong, where it's only updating a portion of the chip. Yeah, either way, something is clearly missing from it, and I'm not sure what. So at this point, I'm going to go and ask for help on the Adamant IT Discord and see if I can get some top tips from someone who can explain to me what I'm doing wrong here. The other thing I'm also going to do is I'm going to do some Google searching and see if I can find an image from somewhere like Badcaps, just a rando BIOS image for this computer that someone has already cleaned. So That's not going to answer my question on what's wrong with it, but it might get me a BIOS image that at least works. I've got two objectives right now. My primary objective is to make the computer work. My secondary objective is to understand what I'm doing wrong here. I would love to know what I've done wrong, but if I get the computer working, my primary objective is still achieved. I return with expert advice, so shout out to Wild Floor Lamp who gave me some top tips on where I was going wrong with this one, so thank you very much. Let's take another look at those BIOS downloads. So the key part that I was missing on this BIOS downloads list is that we've got ROM family SSID numbers here, and that's the big clincher here. Each one of these ROM family numbers corresponds to a different revision of the motherboard. Now, I initially didn't think anything of this because I did actually type in the full serial number of the computer, which is usually enough to narrow down to the exact BIOS version for the computer that you've got in front of you. But that seems to not be the case for, well, at the very least, this computer on HP's website. It also explains why the versioning seems so wonky on these as well, with seemingly random version numbers corresponding to different dates and things like that. So the question is, well, how do we know which one it is then? Theoretically, if I went through all of these and I tried two of them, eventually I'll find the correct one for the motherboard that I'm working on. But there's an easier way of figuring out which one we need. Let's open up the dump file we have. So I'm going to go back to the dump file that I saved from the original BIOS, and I'm going to open this in a hex editor. So I'm just going to open with hexedit, and we need to search for the string $BID, which I assume is board ID. So we'll search for that, and that's popped us down to here. So here we have $BID, and that's followed with 087A4. That's our BID number. So let's take that back to the HP website, and that one corresponds to this BIOS here. Family SSID 87A4. So this is how we know that this is the correct BIOS number. And this is one that I hadn't tried because it is neither the highest version number nor the latest date, which is why I didn't bother trying this specific one. But that's identified it as this specific one. So this is the BIOS I need. So I'm going to download this. And once again, we'll copy the BIOS image to a file location. So I'm surprised that this made a difference, personally. Clearly those other BIOSes are for just different board revisions, and those alternate board revisions will be like different CPUs or having different components added or removed. Does it have the dedicated graphics card fitted? That kind of thing. That would be my assumption on what those other BIOSes are for. But I'm surprised that those are different enough that it actually matters. On a lot of motherboards, like I've said before, that all motherboards do have their own BIOS, but also computers are still modular. We don't need a different BIOS if we've added a different amount of system memory into the computer, for example. DRAM is DRAM. The computer is configured to use whatever DRAM is fitted. So I'm not sure why it's that fussy, but hey, at least we found a solution here and we know why that HP BIOS isn't working. In the meantime, the customer has also agreed to an SSD upgrade on this. So I'm going to pull out this 1TB hard drive clunker and I'm going to back this up and image it onto a SSD. So when we come back, we'll have a newly flashed BIOS chip and we'll have all of the customer's data on a SSD instead. So the computer will be a whole lot faster than it was before. Okay, right, we are turning on with correct BIOS now. Let's see what we get. So we're going to have a couple of other housekeeping bits to do before we're done here. But I just want to get it past post and like booting, and then I'm going to finish reassembling this because we'll be done with hardware at that point. Right. Oh, there was a message there about system BIOS update pending being cleared. And we have a post screen. Just move that so my face isn't blocking it. There we go. Manufacture programming mode is in unlock. Okay, so that's the next bit that we need to deal with, that message that just popped up. It's rebooting again. So because we've got a raw image from HP, this is in programming unlock. So the BIOS is in unlock mode, which means it can be reprogrammed from within Windows, and things like the serial number and the product number ID and stuff like that, none of that information is set. And there's a utility that we can use from within Windows to set these last few parameters up. So I'm going to get this reassembled and on the bench and set up HDMI capture, and we'll walk through how we're going to get those last bits of information in place. Right, so I've got this thing booted up into Windows now, and I've unpacked a tool called the HP BIOS config utility. So you can download this from the HP website, just Google search for it. You can download this, and then you've got to unpack it or install it and get this BIOS config utility. And so what I'm going to do, I'm going to, from an administrative command prompt, and this needs to be command prompt, not PowerShell. Doesn't work in PowerShell, I don't know why. So from an admin command prompt, I'm just going to change directory into the working folder that I've made, which is just C/HP. I'll do a dir there. You can see we've got BIOS config utility here. And so what I'm going to do is I'm going to do BIOS config utility 64.exe /getconfig :config.txt. And what that's going to do is it's going to grab the BIOS configuration and output it to config.txt. So that has completed with no errors. And in my working folder, I've now got this config file here. So if we open that up, and as you can see, now we've got basically 42 different settings for the BIOS configuration here. So there's a few points of interest. The first point of interest is the manufacturing programming mode. So we want to change this to lock, but I'm going to do that last because once we set this to lock, we won't be able to set other settings using the BIOS config utility. So the other things that we need to change is once we come out of programming mode, we will hit another error message where it will complain that this information here is all empty. So our product name, serial number, system family, and so on is all empty. So we want to fill out this information. Now there's two sources for this information. A lot of it we can get from just looking on the back of the computer. So in this instance, on the back of the computer, I've already checked, and I'm just going to type in the serial number and the product number and just any other information I know from written on the back of the computer. So let me quickly do that. And while a bunch of this information is unique to this specific machine, I don't think anyone super cares about a serial number. I'm not aware of any damage you could do with that, so whatever, I guess. So there's our serial number and our product number. And we also know what the build ID is because this was the BIOS we actually used. The BIOS we ended up downloading was 087A4. Which gets shortened, we knock the 0 off the front of it. So that gets shortened to just 87A4. Now we also need the system board CT number. This will be written on the board as a little QR code. So I took a picture of it earlier on. So I'll just type that in as well. And if you don't have a picture of it, I'm going to show you where you can get a bunch of this information out of the BIOS backup image that we took. Because there's the product name, I don't have that written down. So the product name, this is just a string, and I believe this is just vanity. So technically you could put anything you want in here. However, let's roll back to our BIOS backup. So here I've opened the BIOS backup just in a hex editor. So if I search for something that I do know, such as the serial number, I'll just put in the end of that, which is 20MRN. That jumps us down to here and to this block of data. And this might look like gobbledygook, but if we look very closely, there's actually discernible information we can pick out here. So firstly, in this section here, we've got our complete serial number, and that is framed as DMI var number dot the serial number dot nvar. And then if we go a little bit further, there is some junk, and then DMI var another number, and then more stuff dot nvar. And again, we've got this serial number there as well. And if we roll up a little bit further, you'll notice there's some more plain text here. Here, we've got HP all-in-one 24-DF0XXX. So that's our device name. So that's how we know what that is. And again, it starts with we've got dot the string dot nvar. And so we can start extracting information from this. So we've got the name, we've got our serial number. We'll have our product number will be in here as well. If we look a little bit further down, there's the product number, 1C1R0EA #ABU.NVAR. And this is where I'm getting this information from. And we've also got this other stuff here. We've got an F byte, feature byte. And this was another one that is supposed to go in there. I don't know what this feature byte is for, but I'm going to put it in anyway because I can. So I'm going to copy that out. We've also got a build ID here. This is formatted in a bit of a strange way, and I'm not sure if this is correct, but I'm going to put it in as is anyway, and hope for the best, in short. However, I'm not going to lock the BIOS just in case any of this information is wrong. And then finally, if you don't know your CT number, the CT number is further down. If I roll past all of this, there's a bunch of just empty fields and such. And then at the bottom, the CT number is this one here. So for posterity, this is DMI var 0200020700. It comes just before this one that says something something flags. However, pulling data out of the dump file like this, when, like me, you only vaguely know what you're doing here, is rough. So this is kind of a last resort, unless you've got a friend who can say, here's exactly where the data is. So I'm showing you the method here, but that's about as much as I can do. So coming back to the computer now, I'm going to fill out just the remaining information to the best of my ability, and let's see how we do. Okay, so I've filled this out to the best of my ability now. I'm not convinced about the formatting on the feature byte or the build ID. However, I'm just going to see what happens, see if that works. So I'm going to save my config file, so we'll just do file save. And I'm going to come back to the command prompt. And once again, we're going to do BIOS config. And this time, I'm going to do set config, config.txt. So this is going to take the config file and write those settings to the BIOS. And this should come back and tell us all the things that it's updated. All right, so it accepted all of that except the feature byte. Okay, well, I'm not sure I had that correct anyway. Let's just roll with that and see how we go, basically. Okay, I just ran BIOS config on another HP that I've got in the shop, and looks like we don't need that, and we do actually want to cut this extra formatting data out as well, which I didn't think looked right, but just working to the best of my knowledge. Take that out. Okay. Let's try that. Save. Okay, it seems like it still didn't like the feature byte, but it's taken the build ID, and in addition to that, I am really not convinced I'm putting the right information into the feature byte, and also I don't think we even need to set the feature byte either. So I'm going to quit while I'm ahead. So first of all, I'm going to reboot the computer and just make sure that that is all okay. So I'm just going to do start restart. And it's still going to tell us that it's in unlock mode in all probability. Yep, there we go. Now the problem is that we won't know if there's any other problems until we lock programming mode. And after we've locked programming mode, we can't make any more changes. So I'm kind of just going to go full send here and hope for the best. However, setting that data in the BIOS doesn't seem to have caused the computer any significant pain. So I think we'll probably be good. So that being the case, I'm going to set the programming mode to lock. Save the config file, and we'll write that back to the BIOS again. And I'll restart again, and fingers crossed we don't see any error messages from the BIOS screen. And it hasn't come up with anything. It went straight to Windows boot. Excellent. So that is our BIOS now configured. As I say, I'm not 100% certain that the parameters that I put in were all exactly on point. However, I've put in enough information that it works, and I think it's pretty best effort, to be honest. A lot of this information, the computer will run without it, even without all the serial number and stuff. We could have just put the computer into locked mode, and it will complain like, I think it complains once that the serial number isn't set, but after that, it seems to be okay. So I don't think that is strictly necessary, but for the sake of making YouTube videos, I'm doing my best to show best practice, not simply what works. If you want simply what works, you Google search the board number and BIOS and you download some random cleaned BIOS from Badcaps, and you'll get something that works. However, theoretically, this is the method for how you do it properly. So yeah. If anyone's got any corrections for stuff that I've done here, do let me know in the comments down below, just so I know for future reference. I'm sure I made some errors here or there. But past that, this computer is now fully functional again. I'm going to go ahead and service Windows, and then this will be going back to the customer. Thank you everyone for watching, and I'll see you next time. Bye.